Okay, let's dive into this because right now there is just a massive buzz around AI agents. But the real magic? It isn't actually in what one single AI can do. It's in how multiple AI agents collaborate, negotiate, and execute these incredibly complex workflows entirely without human intervention. So in this explainer, we're going to break down exactly how multi-agent systems function together, taking it all the way from the basic mechanics straight through to real-world deployments. I want to hook you immediately with this concept. Multi-agent systems can solve problems that are difficult or impossible for an individual agent or a monolithic system to solve. This right here is the core paradigm shift. We really have to stop thinking about the future of AI as this single, omnipotent, giant brain. Actually, scratch that. The future is a highly coordinated, decentralized team. At its core, a multi-agent system, or MAS, is a computational ecosystem. We're talking about multiple interacting intelligent agents that literally self-organize to achieve goals. Think of it as a decentralized network of specialized digital experts, where every single agent brings its own specific role, its own set of tools, and its own unique perspective to the table. Section 1. The Ant Colony Rulebook. Let's look at swarm intelligence for a second to make this architecture super easy to grasp, just by zooming into a microbiological analogy. And this brilliantly illustrates the shift. We are completely moving away from the traditional centralized boss, that master coordinator delegating every single task, and we're moving toward a decentralized swarm. It's exactly like an ant colony. There is no single boss ant directing traffic or assigning chores, right? Instead, each ant just follows simple local rules. Find food, follow a trail, bring food back. All that complex, highly intelligent collective behavior, it emerges entirely from independent agents just reacting to their environment. But how do digital agents actually do this without a boss? Well, they use the digital equivalent of pheromones through what's called a shared state. Now that might be a digital task board, a message queue, or even just a shared document. Just like ants leave those evaporating chemical trails to coordinate without ever talking face to face, AI agents read and write to this shared state. That's how they understand what's been done and, crucially, what needs doing next. Section 2. From single bots to swarms. So let's move this narrative out of nature and into the evolution of enterprise software. For years, we completely relied on traditional scripted robotic process automation, or RPA. And let's be honest, those bots were incredibly rigid. If a user interface changed even slightly, the bot broke. They just blindly followed canned decision trees. But modern autonomous agentic systems, they are entirely different. They dynamically sense their environment, they actually reason about their goals, and they adapt on the fly. If they hit an error, they don't just crash, they replan, swap tools, or even ask for help. It's a real game changer. Section 3. How AI agents communicate. Let's introduce the mechanical layer here to show exactly how these decentralized agents interact with their digital environment. This is the exact four-step core loop from the hands-on AI playbook. First, observe. An agent independently reads the shared state. Second, decide. Based on its specific capabilities, it figures out what to do. Third, act. It performs the work and updates the shared state. And finally, react. Other agents observe that new update and take their own new actions. Imagine a live production incident at a tech company. A log agent observes an error spike and flags it. A metrics agent decides to check latency, sees a spike, and acts by correlating it with the errors. Then, a deployment agent reacts by checking recent code pushes, finds the culprit, and a remediation agent automatically triggers a rollback. Nobody planned that sequence in advance. It just effortlessly emerged from specialized agents reacting to shared signals. Section 4. The Art of Agent Negotiation. Of course, it isn't always perfectly smooth. Let's pivot to the friction points to see what happens when independent agents have conflicting goals, overlapping tasks, or just limited resources. Now, what's really interesting about this slide is the sheer variety of these protocols. AI agents actually negotiate using methods that feel, well, remarkably human. They use offer response to propose and counter-propose. They use auction-based protocols to literally bid on tasks based on their current workload or cost. They even use voting to aggregate preferences. And get this, argumentation, where agents exchange justifications and challenge each other's assumptions to reach the absolute best outcome. Now, naturally, negotiation introduces some unique failure modes. You definitely have to beware of deadlock and oscillation because, yes, even highly advanced AI agents can get stuck in a passive-aggressive loop of endlessly counter-offering each other or just outright refusing to compromise on a task. They'll just oscillate back and forth forever unless a time limit or a human mediator steps in to break it up. Kind of sounds like a typical office meeting, right? Section 5. Automating Life and Enterprise. Let's shift gears from the theory to some highly relatable practice and see what this looks like when it's deployed in the real world. Consider this wildly fun case study using the OpenClaw framework. This is one user's actual roster of 10 distinct AI agents employed to run their life. So you've got Joe acting as the ultimate supervisor, orchestrating schedules and keeping an eye on the system. Then you have specialized agents like Kaizi, who monitors investment portfolios, and Fudo-san, who handles real estate market analysis. There are even dedicated project agents that strictly isolate context so client meetings don't get mixed up. It is literally a digital staff, perfectly separating their concerns. Let's move to and see how this builds into incredible system resilience. This user actually hosted this on repurposed home machines, and they set up a watchdog script. So if the main PC goes down, the system automatically detects the failure and fails over to a backup PC. The entire swarm is back up and running in just 90 seconds. If one agent fails, the whole system just degrades gracefully rather than halting entirely. But what happens when you take these concepts and scale them up to a massive enterprise deployment? Well, you get numbers like this: 78%. According to recent quantitative studies, deploying agentic AI in the finance sector resulted in a 78% reduction in document processing time compared to the standard human baseline. That is massive. And hey, it's not just about speed. We are looking at an absolutely staggering 92% reduction in error rates over that same baseline. By utilizing swarms of agents that can cross-check each other, acting as planners, executors, and reviewers, companies aren't just getting a quick corporate win, they are previewing the reality of our future workplaces, where multi-agent structures drastically outperform both humans and traditional scripted bots. Section 6. The future of teamwork. Which brings us to our conclusion, focusing heavily on oversight and the broader philosophical implications of multi-agent systems. So the crucial point is that with all this incredible autonomy, governance is absolutely non-negotiable. As the research stresses, enterprise environments rely on strict safety constraints. We're talking least privilege access, strict guardrail prompts, and policy engines that enforce compliance. Most importantly, it requires human-in-the-loop checkpoints at those high-impact decision moments. That's how we ensure these autonomous swarms remain safe, auditable, and perfectly aligned with our actual goals. Because ultimately, all of this forces us to ask a really provocative question. When your AI agents can observe a problem, form a committee, argue over the best approach, negotiate a plan, and then execute it flawlessly without you ever lifting a single finger, who is actually in charge? It's a fascinating frontier. Thanks for joining me on this explainer, and I hope you leave with a much clearer picture of how our AI future will actually be built, not by single algorithms, but by extraordinary digital teams.